they've given you two functions. You've got f of x and you've got g of x, okay? They've given you the actual two equations. What they want you to graph is f of x plus g of x. Now, because we're given the actual equation, okay, this makes our life so much easier because all they're asking you to do is just add this with that, okay? So really all we need to sketch is x squared plus x minus 2, which is just a parabola, correct? Okay, so let's do that. So I'll call this y. So our usual y-intercept is 2. X-intercept is, if I factorize it, oh, sorry. Yeah, thanks. Watch out for me. I'm going to make silly mistakes in the morning. So that's our graph of f of x plus g of x. Seems all easy and simple, right? In the exam, what they usually do is they'll give you the graphs of these two on one number plane, and then you got to be able to actually graphically add those two graphs. Okay, so this is what usually the exam question will be like, all right? They'll give you these two random graphs without the equations, and you need to add these two graphs. And this is a tricky part that you need to pay attention to. Okay, just give me a second. Girls, let's start with, remember, it's all about y values, yeah? Let's start with this point here. This, okay, let me just label which represents what. So this is your f of x, yeah, graph, and this is your g of x, okay? So the y value at that point on f of x graph is minus 2, as you can see. Yeah, minus 2 is the point there. So remember, the question is, what's my question? The question is f of x plus g of x. So we got minus 2, but at that point, from the second graph, what's the y value on that point? 0, okay? So, which means our first point of the new graph is minus 2. Okay, so far with me? Okay, now, second point, let's have a look at this point. Girls, what's the y value of f of x in this graph? Is it 2 or 0? 0. Y value, yeah? It's a y value because if you go across, it's 0. Now, at that same point, if you go all the way to the graph, what's that point like? Give me like a random number. Let's call it, I don't know, let's call it 8. I'm just guessing. Okay? So 0 plus anything is that number. Yeah? So our point, another point on the new actual graph is just there. 8. Does it make sense? 0 plus anything is that. You with me so far, Rebsha? All right, let's keep going. All right, now, let's get a bit tricky. Girls, at this point, right, at this point of f of x graph, let's have a look at that, all right? So girls, we're not going to play with values anymore. So this is the y value of f of x, and from this graph though, this is at that same point, this is the y value of g of x. Can you see that the length of the line is, it looks the same? Yeah. Yeah? So this is like me saying, actually, what's that y value actually if you go across? Minus 1. So what's minus 1 plus, what does that look like? Well, let's say it's 1, yeah? If you go across, let's say it's 1. What's minus 1 plus 1? 0. So my new point on the actual graph is there, 0. So what I'm trying to say is, when you add points on the graph, it's actually easier to look at the length of the line. Okay, you're adding the lengths of the line. Okay, instead of having to actually use the values, that's how you want to do it quickly, more conveniently. Let's just keep going. Let me give you another example. Let's pick that point over there. Okay, so at this line, this is the y value of f of x. At that same line, at this point, this is the y value of g of x. So can you see this time we're going to do a big negative number plus a smaller positive number. Does that make sense? Because here, let's say that's 2, but here it's like minus 3. So, but okay, we're not going to use actual values now because you girls need to start getting used to using the actual lengths. So what I just said was big negative number plus a smaller positive number gives you what? A smaller negative number as a result. So the best way to do it is, girls, what you're doing is you're taking away this much y length from here. So my new point on the graph is actually right here. Okay, so this is my negative y value, and I'm adding that to the y value. Does that make sense so far? I'm going to keep going. It's the same thing. Let's pick another point here. All right. So from here, the y value of f of x is that much. In that same line, if I continue the graph, from at this point, it's always from the x-axis that you're comparing it to get the y value. All right. Let's draw the same vertical line. I'm trying to make it as straight as possible. All right. Now this time, we got a really huge positive number and a negative number. What will be my result y value? Positive or negative? Positive, because we got a bigger positive. So to know exactly where that point might be, basically what you're doing, like I said, is you're taking this portion of the graph and you're minusing it from there. So in purple, so I'm going to take this much away from the end of the graph here. So I'm going to draw about the same length. Okay, tell me if I'm wrong, but I'm just going to be as accurate as I can. So about that much? Yeah? Yeah? So I'm taking this much away because that's the negative part, dragging the positive down. So this is my next point. Sorry?
Are you taking away that from the bottom though?
No. You always start from the end of the graph. Yeah, end of the graph, not from the beginning. And you'll see why. Because that's like the y value, and you drag it down. Yeah, girls, looking by the big dots that I drew, can you see the pattern now? Yeah, so we got the big dots. Let's join them up. Yeah, so this is my final answer. Once you've got enough dots, you can join them up. And as you can see, it's exactly what I've had there. Okay, those are the steps. We're going to apply the same thing to the next graph. All right, so this time, usually the first numbers or the lines that I add is the ones on the y-axis. That's the most easiest to tell. So if you look at the steps, draw a vertical line from a point on the fx graph to the x-axis. Vertical line to the x-axis. That's always going to be the case. Okay, it doesn't matter which one you start. So let's look at that point. Okay, so this one, can you see in blue? That's obviously 1. Yep. What's the y value at this point on the same line? -5, okay? These ones, because you actually have values, all right, we can actually compute the numbers, -5. Yeah? All right, so girls, when we add these two, it goes up to? All right, that's my first point, -4. All right, staying quiet. Okay, girls, now let's do, let's just do any point here. Let's have a look at that point under, we're going to add this with that much. Yeah, so girls, we've got a really huge negative number, and we're adding a positive number. Yeah? So so we are going to take that much away from here. Does that make sense? No?
Yes.
Okay. All right, we're going to take that much away. So that's about. Is that about? Yeah? About that. Is that all right? So I took that much away there. Yes? Girls, sometimes, girls, it's not enough just to do one on this side. Let's just do one more just to get the pattern confirmed. So, let's pick that point because that's the only one that I really got space for. All right. So once again, girls, come on, stay with me. You're being loud. You're taking away that much from the end of the graph. Is that about right? A bit more?
It's not that much. It's not that different from the other one at the top.
Okay, now let's do the same for here. Okay? All right, so now at this point, let's just pick here. I don't know. Let's just pick that. Okay, remember it's from the line to the x-axis. Now at that same point, we've got that much. So as you can see, we're taking away that much away from the end here. So my new point is, yeah? Oh, wait, sorry. Yeah, you're right. Girls, what mistake did I make just there? Girls, this is a negative number, yeah? This is also a negative number. So negative plus another negative gives you a bigger negative down there. So look, I don't obviously have space, so I'll just like put it all the way down there. Does that make sense? If you don't get it, girls, let's say this is minus 1.5, or let's say it's minus 2, right? So we've got minus 2, and you're plussing on that point of the negative. I'm just confirming. All right, girls, I'll just get right to the chase. Usually in the exam, this one, can you see why it's confusing? Would that be enough to tell you what the graph will look like?
Yes.
What is it?
It's like a diamond.
Very good, it is.
Whoa! She's so sick of this.
Yeah, it's meant to be a yeah. Girls, that's the end result, which doesn't look the best. But here's a general fact. In general, girls, when I say higher value parabola, I mean like it can be higher positive net value or higher negative value. Yep, so that's your general fact. Whatever. Just yeah, all right. I was a bit ambiguous about that note. Just yeah, just another parabola, but like either more negative or either more positive. That's what I was trying to say about higher value.
Yeah.
All right, take a photo. I've got 2 more examples for you now. Did I draw that right? Yeah. Okay. All right. That's not accurate. Okay, so let's have a look at the result when we add a cubic with a parabola. Okay, so let's do the same thing. Let's start with the easiest. See right there, see how they both meet at 0? So 0 plus 0 is 0. Yeah, let's start with that. I won't have to write it. All right, what's another obvious one? Doesn't it? Okay, actually, any point that intersects, it means they both have the same, let's say, I don't know, let's say that's 7, right? 7 plus 7, 14. So any point where they intersect, it just doubles. So see that amount? See that amount? 7 plus 7, you want to, so it's going to be really, it's okay. Bad scale, but let's say the end result is there. Does that make sense? Same number. The number. So this is like a point, once again, point where 2 graphs intersect. Okay? So that's like another fact. All right? All right. What else? Girls, this can be pretty tricky, so stay with me. I'm just picking random points here. So let's have a look at these values here. Girls, you need to actually be careful with this or like you're going to make a silly mistake. All right, so this is that value. Now, for this parabola on the same line, we've got that much. So that's a negative value plus another negative value. So you're plussing that much more to the end. Does that make sense? Sorry? Negative plus another negative. Let's do the same thing here, just randomly. This much. And at that same line, we've got that much. So what's happening here? So you got some number plus another positive number. So I'm adding this much on top of here, yeah? Does that make sense? I'm adding that much on. So good? Yep. And at the same line, let's go all the way to the graph. All right, what's happening here? You got a really huge negative number and you're adding another smaller negative number. So am I going to go more down?
Yes.
Yeah, you're adding more negative value to the top here or to the bottom there. Based on the dots, what does it look like? It's actually not.
It's a thingy, it's not cubic.
Another cubic. It looks straight line, but it's meant to be cubic. If you look at this at a bigger scale, it's actually another cubic. Okay, so what am I trying to say? Another in general fact? Yeah, another higher value cubic. Okay, so the way to look at it is, take a photo of that. So when you have, girls listening while you're taking, previously when we had a problem in a straight line, girls, which graph has a higher power, parabola or a straight line? Okay, I'll get out the photo. Obviously a parabola. So the end result is the graph of the higher power. Does that make sense?
Yeah.
Prediction. Shh, girls, let's have a look at a prediction.
But then the opposite.
Prediction. If you have parabolas of the opposite sign, so obviously you've got a concave up and concave down, if you add those opposing parabolas, what do you think you'll get? Just take a guess. Straight line. You're exactly right. Okay, let's have a look at that. The point, it's going to look like that. Let me just write this down in general. All right, I think you girls get the point.